You'll learn what a population is and what a sample is, and how they differ. We'll introduce the notion of simple random sampling as a way to select samples, and we'll describe the difference between two sampling methods, sampling with replacement and sampling without replacement. First, let's talk about populations and samples, what they are, and how they differ. You can think of populations and samples as sets of data. The main difference between populations and samples has to do with how observations are assigned to the data set. A population includes each element from the entire set of observations that can be made. A sample includes one or more observations from the population. By the way, another difference between populations and samples has to do with nomenclature. A measurable characteristic of a population is called a parameter, and a characteristic of a sample is called a statistic. For example, suppose we compute a mean score of a population data set. We would say the mean score is a population parameter. But if we compute the mean score of a sample data set, we would say the mean score is a sample statistic. Sample statistics are often used to estimate population parameters. A sampling method is a procedure for selecting sample observations from a population. There are many types of sampling methods, but in this tutorial we will focus on one method, a method called simple random sampling. Simple random sampling has three defining characteristics. First, the population has a specified number of objects, which is denoted by the capital letter N. Second, the sample also has a specified number of objects, which is denoted by the lowercase letter n. Third, all possible samples of size n are equally likely to occur. To illustrate how to select a sample that has these characteristics, let's look at an example. Suppose we had a population of 3 observations, and we wanted to select a simple random sample of 2 observations. One way to do this would be the lottery method. First, give each population member a unique number. Second, place the numbers in a bowl and mix them up. And finally, ask a blindfolded researcher to select 2 numbers from the bowl. Population members having a selected number would be in the sample. Notice that the sample selected by this method is based entirely on chance. Every possible sample of size 2 is equally likely to be selected. A third of the time, the sample will include observations 1 and 2. A third of the time, it will include observations 1 and 3. And a third of the time, it will include observations 2 and 3. That is, every sample of size 2 has an equal likelihood of occurring. And that is the main requirement for simple random sampling. All samples of a particular size are equally likely to occur. And finally, there are 2 twists on sampling that we need to describe: sampling with replacement and sampling without replacement. Broadly speaking, there are 2 ways to select samples: with replacement and without replacement. Suppose we use the lottery method to select a simple random sample. After we pick a number from the bowl, we can set it aside or put it back in the bowl. If we put it back, it may be selected more than once. If we set it aside, it can only be selected one time. We are sampling with replacement when the population element can be selected more than one time. We are sampling without replacement when the population element can be selected only one time. Notice the effect on sample size. When you sample with replacement, sample size can take on any value from 1 to plus infinity. But when you sample without replacement, sample size can be no bigger than population size. Let's review. In this lesson, we described two important types of data sets: populations and samples. Populations include all of the observations that can be made. Population attributes, like the mean or standard deviation, are called parameters. Samples include one or more observations selected from the population. Sample attributes are called statistics. We also talked about a way to select sample elements from a population called simple random sampling. With simple random sampling, all possible samples of size n are equally likely to occur. And finally, we compared sampling with replacement and sampling without replacement. When a population element can be sampled more than one time,